Okay, we're going to talk about squares and square roots now. So for 77 through 80, the directions say find the two square roots of each number. When we're talking about two square roots, remember we can have positive and negatives. We can use that quick sign, that plus minus sign. So for 77, what two numbers multiplied by itself equal 9? This would be positive negative 3. 78, positive negative, or 64, yeah, number 78, we're talking about 64. So the square root of 64 is positive negative 8. For 144, positive negative 12. And for 80, it's going to be positive and negative 15 for my final answer there. Make sure you list both of those. There's 2 points available for each one. You make sure you talk about the negative and the positive. You can list them both out. If you don't use that symbol, that's totally okay. For 81 and 82, it says evaluate each expression and show all work. So remember, when we're talking about evaluating expressions, we only use positive roots. So only use the positive roots when we're talking about evaluating expression. So what we're going to do first is evaluate what's in the parentheses first. We're still following the order of PEMDAS here. Remember that square roots are technically in the E right there. So parentheses first, so 6 plus 75 is square root, or is 81. So it's actually the square root of 81 is what we're looking at. Since we're evaluating, the square root of 81 is just positive 9. Now, if we were just looking at the square root of 81, it would be positive and negative. But since we're using this in an expression, final answer is just 9 there. For 82, the square root of 169, again, we're using the positive square root there, or the principal square root is what we would call it. The principal square root is always that positive root of a number. So that's 13 over 24. So we're going to leave it there, 13 over 24. For 83 and 84, we are finding the two integers each square root falls between. So now I'm thinking square roots, you guys have that reference sheet that lists perfect squares, I think up to 100. So the two roots that are in between, or that surround the square root of 123, the lower root would be square root of 121, and the upper root, the bigger root, would be 144. So square root of 121 is 11, square root of 144 is 12. So the two integers each square root falls between is 11 and 12 for number 83. We're going to do the same process for number 84. The lower root is 49, and the bigger root, the upper root, is 64. So that is 7 and 8. Now, we have to make sure we don't just stop at listing what two roots surround the root that we're given. We have to go to the integers because we're finding the two integers. That's what our directions say there. So remember, we take it one more step and find the actual root of those numbers. Okay, now we're into real numbers. So write all the names that apply to each number. Remember, we made a foldable for this as well. There's real numbers, or there's not real numbers. So as long as everything's a real number, you can either look into rational, irrational. So I'm going to draw a little tree for us. Real, rational numbers, irrational numbers. And once we get to irrational, we stop. Integers. Non-integers. And then into integers, we have whole numbers. Okay, so write all names that apply to each number. So for number 85, we're going to look here, and it's the square root of 81, which in this case is 9. So we know that is a real number. That number exists. Rational, you can write it as a fraction. It is an integer, it's an integer, which means it doesn't have any decimal. So integer. And it's a whole number because it's positive. Number 86, the square root of 7, that's not a perfect square, but square root of 7 we can find. If we plug that in our calculator, we could find that. So that is a real number. Now, irrational means it does not end or repeat. Square root of 7 is not a perfect square, so we know that's irrational. So we would stop and write irrational here. And since it's irrational, we can't get any more specific there, so we would just go on. We're finished with that one. So number 85, all four for that one, real, rational, integer, and whole. And for 86, it's real and irrational. Now for 87 and 88, directions changed slightly, so we have to make sure we're paying attention to these changes. It says state if the number is rational, irrational, or not a real number. One out of the three we choose. So 87 is the square root of negative 15 over 49. Now, right when we see this negative sign, we can't take the square root of a negative number. So this is not a real number. For 88, we're 7 over 0. We can never have a 0 in the denominator. So again, this is not a real number. And that's all it's asking us to do. So once we write these, again, we're done. We can move on. For 89 and 90, we're talking about Pythagorean theorem. It says solve for each unknown side of each right triangle. Be sure to write out the formula. Write out the formula used and show all of our work. Now we have to write the formula each time we're doing this. And the Pythagorean theorem is that a squared plus b squared equals c squared. Again, draw a picture. Draw a right triangle. Make sure we're paying attention to what units we're using. In this case, it's inches. And we're going to label what we know. Now, A and B are the legs of the triangle. C is always the hypotenuse, the longest side of the triangle. So I know C is 20, so I'm going to label 20 there. The hypotenuse is always diagonal from our right angle. Now, A and B can be either one of these legs, doesn't matter. So A, we don't know. B is 16. So we have a squared plus b squared equals c squared. We don't know a, so we're going to leave it a squared plus 16 squared equals 20 squared. Now, again, a squared stays there. 16 squared is 256, and 20 squared is 400. So then we're going to try and solve for a squared. So now this is just a one-step equation, or in this case, it's a multi-step equation. But what we're doing is we have to isolate our variable first. So we're going to subtract 256 from both sides. And a squared equals 144. But we want to find what a is, not a squared. So we take the square root of both sides. We have a equaling 12. And then we make sure we use our units. So 12 inches. So that's our final answer. A, side length A is 12 inches. Same thing for 90. We're doing the same thing. And we're going to write a squared plus b squared equals c squared. I want to see that on every single question like this. I want to see a picture. C we don't know, so I'm going to put a question mark there. A and B, again, can change. You can put A and B whichever way you want. So I'm going to put 6 here, 8 here. We have 6 squared plus 8 squared equals c squared. 6 squared is 36. 8 squared, 64 equals c squared. 100 equals c squared. I want to solve for c, so I take the square root of both sides. And 10 equals c. But we need to make sure that we use our units once again. So it's 10 feet equals c is our final answer for that one.